The Mapping and Charting Establishment has a proud history of providing geographical support services to the Canadian Forces in times of war, peacekeeping, and training. Traditional methods of positioning have served well and have grown in terms of speed and accuracy, but none can match the revolutionary positioning tool, GPS. Before we see how GPS is used in the field, let's look at the way it works. Traditional optical and electronic survey systems depend upon a clear line of sight path to work. Obstacles and adverse weather can frustrate these methods. GPS uses satellites, which transmit a coded signal to portable receivers on the ground, thus avoiding obstacles. We know the speed of radio signals and the known satellite orbit characteristics. With the addition of 2 more signal sources and through simple geometry, we can establish a 2-dimensional position for a receiver on the ground. Because the signal transmission time from the satellite to the receiver is an integral part of the calculations, a 4th satellite is used to correct for clock errors, differences which may occur among the receivers and the satellite's clocks. The correct complement of 4 visible satellites provides accurate 3-dimensional positioning. GPS is an all-weather 24-hour-a-day facility provided for by a globe-covering constellation of satellites. Now let's see how this works in the field. Let's say we have to determine precise locations for military units. Working with local maps can be very risky because of inherent errors. They may be based upon the wrong datum or may be completely out of date. Any military operation needs careful planning, and in the high-tech world of GPS, it's especially important. The GPS mission plan takes into account the satellite's positions and availability. The degree of accuracy depends upon the type of signal code to be used and the method. For navigational purposes, a single receiver using the CA code is accurate to 100 meters. Military users may access the encrypted version of the P code, known as the Y code, to obtain 10-meter accuracy. MCE personnel go to the planned positions and commence their work. This may involve a number of GPS units depending upon the size and complexity of the survey. Using differential GPS with 2 or more receivers, MCE can provide positioning to millimeter accuracy. GPS is a very efficient way to obtain accurate positions. Its computerized technology takes into account errors from variables in propagation and satellite position. In a matter of minutes, the equipment can be set up to receive data based upon the mission plan specifications. But if you're working in a hostile situation, how vulnerable is GPS to enemy interference? Well, GPS reception might be affected by jamming or spoofing. Jamming is produced by land or airborne transmitters. These transmitters are active devices which can be traced and neutralized. In some situations, the GPS user can shield himself from jamming. Jamming is further reduced by the use of special antennas and GPS signals having a higher signal-to-noise ratio. GPS reception might be spoofed by a hostile look-alike signal. To counter this, GPS satellites transmit the encrypted Y code. Thus, it can only be decoded by an auxiliary output chip in the receiver. Unlike survey equipment such as Doppler or EDM, which generate their own detectable signals, the GPS antenna is passive. It produces no detectable signals. In all, the vulnerability factors for GPS are very low. Once the GPS data has been stored in the receivers, it's fed into a field computer for post-processing. Within minutes, precise position can be calculated. Coordinate information may be radioed to Field HQ, or hard copy may be hand-delivered. It's done. Using GPS, these positions were surveyed to sub-meter accuracy in a matter of hours. Using traditional survey methods, this could have taken days. Because of their portability, GPS receivers can be used practically anywhere. MCE personnel can train others in the use of GPS. Once the geographic datum is known, the setup procedure and operation is not difficult, and it can be used in combination with traditional survey methods. But the interpretation of the GPS data can be a complex process, and the results easily misunderstood by those lacking a thorough knowledge of the system. The Global Positioning System. It's fast, it's accurate, and it's versatile. Through the Mapping and Charting Establishment, the Canadian Forces can benefit from this technology now.